and welcome to another video of CS202. Don't mind me, I am just relaxing here and enjoying my day because today we're talking about a wonderful thing known as object-oriented programming. So it's a big deal. It's going to grow you as a programmer, and it's going to kind of open our eyes to a bigger world. So even though I just had it for the last 10 seconds about object-oriented programming, let me talk about something else for a little bit and then kind of build our way up to such a amazing thing. All right, so what is it that I want to talk about first? Well, I would like to tell you what a class is. And now I'm not talking about a class like CS202. I'm talking about a class in C++ programming. So what is a class? Well, it turns out that a class is nothing more than what you learn in CS135 that a struct was. So let's kind of start out by refreshing ourselves into what a struct is in 135, and then kind of see what I mean by saying that really classes and structs are pretty much the same with one tiny little difference, like small font kind of difference. Well, okay, what do you use structs for in CS135? Well, what you use them is as a record of information, right? So normally when you're writing a variable in C++, you can only keep one data type, right? So even if you make a list, or an array, actually is a more proper term for 135, if you make an array of a data type, so like an integer array, or a double array, or a float array, or even a string array, it can only keep one type of information, which is the data type that the array is, right? It is known as a homogeneous data structure. Okay, cool, but what if you want to keep multiple things? Well, you have to do separate variables, and it's not very, it kind of gets messy once things, like if you're trying to say, do a student record, and the student has a name, a birthday, some numerical information like account, how much money they have, all those kind of things. GPA, which is a double. It might have, even things like Boolean flags, has the student graduated or not. So ultimately, if you want to keep track of all of that for a student, you could make a bunch of arrays, and then like if you're making a bunch of arrays, what you can kind of try to do is like use the index of the array to have like the matching information. So like this is a string array. It keeps like the name of the student, and here's like an integer array. Or here, let's do a double one here. It keeps like GPA. For integer, we can do like their age. And this is something else, right? So like we can say like index 222. That is going to have the name John Wick. Age, how old is John Wick? I don't know, 50s? Let's just 50s. Okay, well let's just say 50. And the GPA, I think he'd be like a pretty smart dude, right? So you got John Wick there. So I mean, yeah, sure, you can use the index as a way to keep track of things, but it gets really messy, right? So we learned that structs can kind of alleviate this, because a struct can have multiple variables inside of it. So my struct can now have an integer for age in it. It can have a GPA, yeah, double GPA. Double GPA, string name, and so on, right? And by the way, let's actually refresh the syntax of how to actually write a struct. So remember, C++ is white space insensitive. However, we do want to keep some nice etiquette and how we space out our code. So one of the things that is good to do is to tab variables and things like that. So we can do something like struct. We'll call this, I would call it student, but I'm out of space here, so I'm just going to call it S. And then you have an opening bracket, kind of an KNR, my own version of it, and a semicolon, right? The semicolon is kind of tricky, because like you think of functions and things like that, and it doesn't have that semicolon there, but classes or structs do. And so here you go. In my head, I'm thinking I'm in like my tablet, because in my head I was like, let me just highlight this and scroll it over a little bit to like shorten the space there. But I'm like, wait, no, this is a board. But yeah. So ultimately, this is nice because now if I want to make an array of these, I can. You know, something like here. S1. Okay, so like here we have struct student making array with the variable name S1 of size 10. Okay, fixed array. So you could do something like that. And so now if you want to access an element of this, you can say something like S1. Let's say we were accessing the third element, so because indexing starts at 0, that's 0, 1, 2. And then you use the dot, which is known as the member access operator. Maybe that's a good refresher that we write that up here. Okay, so we use the member access operator, and then we write the member that we're trying to access. So let's say we're trying to get the age. So we can do that, and then, you know, we can like see out this or something. And this is going to see out, oh, got my handful of ink. This is going to see out the age of the third student, per se. Okay? So that's cool. That's all hopefully a review from 135 of what a struct is. So now let's go back to the question about what a class is. So a class is nothing more than a struct. In fact, the keyword struct is sort of there, has a name that just left my mind for a second. Legacy. It's kind of like legacy code from the C days. So in C, C is a programming language. Hopefully you all know that. And that programming language is older than C++. And when C++ was made, they kind of wanted to kind of capture the audience of people that like C, but they wanted to not have to do everything so like bare bones, right? And they introduced object-oriented programming and all these great things in C++, but they still wanted, again, to make it easier for someone coming in from C. And so a struct in C is very similar to a struct in C++ with some with some serious differences and when you can and can't do. And while I'm not going to go too in depth on that, but I do welcome you to check that out. Go ahead and Google it, C versus C++, structs or something. Ultimately, in C++, the structs there, while they will work with C code for like 99.9% of the cases, they really work as a class in C++. And what I'm saying is, like, if I recall correctly, you can't have a function in a C struct, whereas you can in a C++ struct. But there's workarounds about that using function pointers and other nastiness that I've done before, and it's not fun, but it works. It's like trying to make C object-oriented programming language when it's not, can just be nasty. But it'll work, you know. If there's a will, there's a way. Life finds a way, kind of thing. But ultimately, you probably didn't see that, though. You probably didn't see a function inside a struct in 135. And if you did, that's cool. You're ahead of the curve. But let me show you that really fast. So what do I mean by having functions inside of structs? Just that. I could go ahead and write a function here called void print age. No parameters. And I could write anything here, actually. You could just go see out high, or better yet, we could actually print out the age of this little, I'm going to use a term that's brand new, but object. I'll come back to those terms though. I could say something like cout age. Imagine there's some line feed there, okay? So I'm jumping a little bit ahead by doing this, but I just wanted to bring up a point that you can have functions in C++, and I am going to talk about more about like what this age is doing in this case. But for now, just know that what you could do with a struct, you can do with a class, because they really are the same. Now, what is that tiny difference that I said they have in C++? Well, we are going to talk about this. I don't know if we'll talk about it today in this video or in the next video, but the information and who can access it depends between a class and a struct. So with a struct, I can write something like this in any part of the program. And as long as I have access to this array, then I have access to whatever the array contains. So everything is public. That's the keyword for this. However, classes are actually private by default. And so I'll have to talk about the comparison between public and private and how it affects classes versus structs, but I did want to bring up that is the difference. Like I said, a lot of brand new things being thrown at you. I understand that. We'll work through all of them, and by the end of this all will make sense. Okay, so let's go ahead and get some extra space here. So what I'm going to do next is I'm going to go ahead and write the definition of what a class is. And if you watched the last video on function overloading, then you saw me use the term polymorphism, and I said that was something important when it comes to what object-oriented programming is. And it is. Don't take that back in any way. But you know, there are other important things that are part of object-oriented programming that's I'm going to also bring up. So that will come back. So you know, if you just watched that video and I left you in a cliffhanger, then we'll get you going there, and then we'll end this video with another cliffhanger, right? That's how you keep you hooked. I don't know if we'll end up in the cliffhanger, unless like power runs out in the middle of the video. I think that this will be a nice and whole lecture. So, what is a class? A class is going to be a collection of a fixed number of components. Sounds simple enough. The squeaking stuff is going to get to me. Should I just embrace it and be extra squeaky? Okay? Components, plural. Okay? So a fixed number of components. What do I mean by fixed number? Well, you know, unless you're like in math, things are usually finite, you know, in computer science. Like we like to think of things as finite. Like we have finite amount of memory, finite amount of money to buy like, overpriced GPUs. Things have a fixed amount, okay? And so while theoretically you might say like numbers are infinite and range of numbers is infinite and that kind of thing, as CS people, we like to keep things finite. And so when it, you know, this is no different than that. We're saying that a struct or a class, you know, it has things in it, such as what we saw here, age and the name and the GPA, but it's like a fixed number of them. It doesn't just randomly change. And it's not an infinite list of things, right? Otherwise, like, what would you have to, if I asked you to name them all, like, would you just go and infinitely speak? No, I mean, you have to have a fixed amount. So that's what I mean by fixed. And by components, I'm just talking about what's in them. So what is in them, actually? Well, you saw a bunch of variables, but also potentially functions, right? So let's go ahead and just do that. On one side, we have things like variables. They can be in a class. Other names for variables that you will see used in books and whatnot are things like fields. I think the Java people like that term a lot. And over here, we have functions. Another term that I think you might even hear me say for instead of function is the word method. Depending on who you ask, these terms could be interchangeable. Some people say function is like a value returning function versus like a void function would be a method. Some people say that like all functions inside a class are known as methods and member methods. So I don't care which ones you use. If you're like on a test or something, you write. For me, they're interchangeable, just like how that one's a little bit more defined, but I just mix them a lot. Parameter and arguments in the last video. But yeah, so this is what a class is. It's a collection of components that are going to either be functions, variables, or both. I'm not saying they have to have both or that like it cannot have both. I'm just saying it can just be whatever you want from either of these groups and so on. Okay? So, cool, that's a class. Now, going back to the question, what is object-oriented programming? Which, by the way, a term that is sometimes abbreviated as OOP, okay? Well, first let's talk about the word object, because I did actually mention that word earlier, okay? So the word object, so you're saying, so you're programming based on objects. When you have a class and you're actually instantiating that class, so you're actually creating a student out of your student struct or student class, you're making objects. And so these objects are going to actually contain your functions and variables, okay? Now, what does that compare against? Well, in classes like 135, you did what is known as imperative programming, I believe. And that's just, you're writing your code and you have a bunch of functions. There are other types of programming, such as functional programming. I don't know if there's a class actually, no, there is. What am I saying? There is a class, but I don't know if there's an undergraduate class. But there is a graduate level class that talks about functional programming, taught by Dr. Peterson, who teaches the compilers class. I think some undergrads sometimes take it, so that's something if you're really interested in, you could definitely do. But for now, I'll just say that functional programming can get trippy, and it's all about functions. And when we talk about recursion, that's kind of what functional programming is. It's just like recursion galore. But yeah, going back to this, object-oriented programming is within imperative programming, sort of like a type of programming where instead of just like blobbing everything together like on your code, you want to sort of compartmentalize it or encapsulate it into all of these little things that you want to do. Okay? So let's before I go further with the object-oriented programming definition, let's kind of think about how we want to, like, why we want to have functions in the class rather than just variables, okay? So you have to kind of change your mindset as to how you program. When you're programming, you're usually dealing with data, right? Like, that's the honest truth. Like, you have some form of data. If you didn't have any data, then your code would just be like a script that just starts and finishes and nothing exciting happens, right? Are there things like that? Sure. Like, if you have very basic code that just does something, I mean, sure. But a lot of the times, you want to write more complicated code, right? And sometimes what you want to do with code, and it's hard, it's a hard thing to do when you're starting out the code, is converting the real world into programming. And what do I mean by that? Suppose that I went ahead and said, okay, I would like you to develop for me a self-driving program, AI. Like Elon Musk comes in and says like, yo man, we need some help with Tesla's AI. So please help us, develop a simulator so that we can test our AI and improve the neural networks in it. You're like, oh snap, okay, that's a big task, but all right, why not? Sure. Okay, so the first thing you gotta do there is represent the data that you're gonna work with. And one of the kind of crucial things in that example would be to have a car, right? So you would want to represent the car in all of the different things that a car has and what it does. And so you would think about object-oriented programming and how you would develop a class that is known as the car class, in this case, that can contain that information. So what kind of things would you want it to have? Well, if it's a car, it's going to have some data that's going to be like telemetry data. So things such as the current speed or velocity of the car. Obviously, these are not equal terms. I believe velocity also is going to have a vector in direction, but let's just, for use simple method, just do speed. It's also going to have things like booleans like status, whether the car is in on or off position, or other different kind of statuses, kind of things like, is the person in the car, is the person looking at the road, because I know Tesla, you gotta touch it, I think, so that it doesn't disengage the auto drive. It could have things related to temperature. It could also have static information that it needs to know. For example, the maximum speed. So if there's a governor or something for the car that limits the maximum amount of speed that it can have. Also, cars have what is that? The VIN? Yeah, the VIN. I think it's just VIN, right? So that's the unique ID of the car. If it gets stolen, that's what they can use to track the car and whatnot. So these are things that are once you set them, you're good to go for the most part. And then these are things that are going to be changing up here. So those are some of the data that you could have. Now you could have tons and tons of more, obviously, but this is just a simple example. Now, what kind of operations would you want to have that a car would do? Well, a lot of them. In the most basic sense, forgetting a little bit of like auto drive, just like basic operations of a car is you want it to be able to accelerate, right? So you want it to be able to move, you need to change its speed. So you need to have accelerate, you need to be able to have it actually move. Accelerate, right? Obviously, if you make something move, you better very quickly code something to make it stop, unless you want to crash and burn, right? So, yeah, that is probably something you want to code. In fact, I would code the brake first before the accelerate. But how do you test it? I guess you just kind of hope for the best. Well, the brake was coded correctly. Well, it's a simulation at the end of the day, so if it explodes, so you're like, yeah, it's okay, simulate it. What other things would you want to have? Well, you probably want to have a start and stop, so like some kind of on switch. So, yeah, just have a function that starts the car and another one that stops the car. Okay. And you could have obviously, again, a lot of more things in here, like enable AI, disable the AI, enable the AC, turn off the AC. Then you have something here to keep track whether the AC is on, the temperature of the AC, and temperature of the car, and how much fuel you have left, or I guess how much electricity you have left, and how much are you consuming. Yeah, like, obviously, if this was real, you'd have like a ton of different variables and a ton of different operations, right, or functions. Okay, now these operations, they're not any kind of operations, but like these things will, pretty much all of them are going to have some sort of interaction with the data of the car, right? So for example, we got our accelerator and our brake. What are they going to be doing? Well, they're going to be changing our current speed, right? If you accelerate, the speed's going to go up. And if you decelerate / brake, then it's going, hopefully you're decelerating when you're braking, otherwise bad things will happen. The speed's going to decrease, right? I mean, obviously, if you're asking like a math person, they're going to be like, oh, acceleration doesn't always mean positive. Acceleration could actually be decrease velocity, but ignore them for now. We're making this simple. Okay? And things like start and stop are going to modify something as simple as like our status, which is whether the car is on or off. Also, the accelerate function may not just be a simple increase or decrease of our speed. There might actually be additional checks there that are coming from the max speed variable here, or constant, I guess. Right? We might have a little if statement that says if the speed we're accelerating to is trying to go over what the max speed is, then we just reject that acceleration request. Things like that. And then the bin probably not going to be accessed by any of these, but we might have a function here that says print bin. And so if you just want to see the bin, or maybe just print manufacturer information, and among those things we see the bin and other of the variables here, like the brand, Tesla or whatever self-driving car you are interested in. Okay, so why are we doing all of this? Well, because once we develop this object that is containing all of our cars, then we can actually use this and represent the movement of the car in the digital world. So we can accelerate the car, brake it. It's like we're playing a little video game. Now we have a little player car, and we can now develop a class for the world and a class for the road and things like that. And we can move things around and test things and see how it works. So object-oriented programming and doing this sort of preparation and then converting this into a class really helps you sort of convert real-world things into objects and classes. Okay, how would we do this for this? Well, you already kind of saw how I converted this into functions, but let's actually write the class that would do this, okay? Now, it's going to be a little tricky here with the space. Obviously, I'm trying to write big because otherwise it's hard to read, but that also means that I run out of space. So let's actually let's get rid of this. I think we all know what class we're in. All right, this is Cooking 101. Or actually, no, this is Drawing 101, Bob Ross Drawing. But yeah, so let's go ahead and write a class. And obviously my class is going to be compressed and it's going to look super pretty because I have the space, but yours will when you're trying this at home, right? So what do we want to call our car, or class? Well, car. Naming convention for classes. You know, I'm weird about this. This is my thing. I like to uppercase the letter of the variables for classes to help me differentiate between the name of a class and the name of an actual object of that class. So like, you know, if we're doing the struct for students, and I want to make this name the struct student with a capital S, and then if I'm making an actual student like instance of that struct, I would lowercase that. That's my own like internal way of organization. But you're more than welcome to do whatever you want. What I wouldn't recommend you do is like uppercase the class names. That's more of meant for like a constant, and that's like I think that's the more traditional usage of that. Like if you're using a define. So yeah, I think this is a good middle ground for making it easy to read. Or if you want to go old school, people will call it add the word type at the end of the variable name. Like they'll do some camel case or they'll do an underscore or something, and then they'll add the word type. So like you make a car type, boat type, book type, student type. And that's because like in a way, when you're building a class or a struct, you're sort of building your own custom data type, right? So like a string, you know, some people will yell at me like on the comments or something, but I'm going to go ahead and say, you know, a string is like an array of characters, right? And characters are just a data type. So really, a string could be like you know, it's just made up of other existing data types. It's not like a pure data type that's completely different. In fact, the car is just numbers. So I could say the same thing about a car, right? Whereas doubles is actually like its own weird nastiness that you'll learn you'll learn the IEEE standard for floating point notation when you take 218. But yeah, so that's kind of its own actual thing. But the other ones are sort of built up with other ones, right? And our car type is built up of things that are like built into the language, like integers and floats and strings. So when you're building this data type, it would make sense to call it something type at the end. And so it's easy for someone else to read that. Remember, documentation is very important in programming. You want to always add as much documentation as you can, but that doesn't mean that you're leaving the entire weight of documenting your code to like comments. You should also be writing self-documenting code. Now be careful, and some people triggered me on Discord some time ago about this. Writing self-documenting code is not enough to actually have well-documented code. That's not the point. You should do that, but you should still add additional documentation to clarify what that code is doing there, okay? It's not always 100% clear from self-documenting code what code will do, and always document more, never less. That's a good lifestyle to do, okay? Anyways, car type is cool and all, but I'm gonna go with car. Okay. So, class car. Not a fan of that curly brace. Yeah, all right. Okay, so I'm going to put in the keyword here. I said, you know, if you were here from the beginning of the video and you didn't just fast forward, you heard me mention this thing about public, private, and the difference between a struct and a car. We will return to this keyword, but for now, I'm just going to put it here, and these are colons that I am putting there. Okay? I'll come back and tell you what happens with this. Probably maybe next lecture or the one after, I'm going to be in the computer playing around with this code, and you'll get to see it. Actually, I mean, I could really quickly draft up and show you that. But yeah, for now, we're just going to put that there and kind of forget it for a minute. Just like in 135, when you're using things like, you know, like length and string, and you didn't know what functions were, but you're still using functions in a way. In fact, all this time you've been using cout, and you don't really know how cout works. Like what is an OS stream and things like that. You're going to learn that this semester actually when you do operator overloading. But yeah, you just kind of assume and do those things, right? So similarly here, just for now, just embrace that this is part of what you have to write. Okay, so now that you've done that, let's go ahead and start throwing in some variables. So like for speed, you know, I mean, I could make that an integer, but if I want more precision, I think a double or even a double would be good. I'm not a fan of floats. You could also, by the way, if you're compiling, which you really should these days, compiling in modern C++, like std C++ 11 at least. So very quickly, if you don't know this, shame on you. But if you're trying to compile a program, you would use something like G++, pass in the argument of the program, the name, and then from there, you can do -std equals, and then you can pass in the compiler version that you want. So if you pass C++11, that is going to compile with a more modern version of C++. And I don't know what the default is on your machine or on whatever you're compiling. So it could be 11, it could be 98, it could be 17. I don't know. But this sort of removes that ambiguity by telling you which version you want. If you want to use like a newer version, you could use 17. I would not go over that. Depending on what year you're watching this video, this is, you know, like 21 or 20. Yeah, 21 is. I don't think that is fully developed. I think that's the safer one for now. Obviously, you know, watching this in 2030, then why are you watching such an old video, first of all? But second of all, you probably use a newer version. So yeah, but at least use 11. You know, that's a nice. That'll get you everything that would otherwise give you errors, like if you're using S2Y, you know, string to integer. That's a good one that is not available in older ones. So yeah, but yeah. Anyways, so if you're using C++11 or later, then you can actually initialize what the speed variable is going to be. So when you make an object, or even if when you're doing structs, you know, when you do any variable, even like just an integer, you know, if I go ahead and write something like int a, and then I say cout a, what is that going to print? You know, what if I said like, I will give you $1 million if you guess correctly what that's going to be? Like, but if you guess it wrong, you got to pay me $100,000. You're like, oh, this is some good odds, 10 to 1 kind of thing. But would you really take that? Because I mean, technically speaking, the people that develop C++, they said that this is like, you know, whatever. Like, when you're allocating this piece of memory, and we will learn about memory in a couple of weeks, you are basically saying, yo, operating system, give me a spot in your computer, like your memory, that can store an integer. And they're like, sure, yeah, take lot 5218. And when you get to lot 5218, that is not new. It could have been used by another program at some point, or it could have been just like fresh off, you know, brand new, fresh. Ultimately, though, that's not defined. It depends on just whatever you get. So it could have random data. Some compilers, like when you start a program and you execute it, they will initialize these kind of things to 0, especially if you're running it in like a debugger. And that is very misleading because that may not always be the case, and that is how bugs are born. So don't do that. What do you do to avoid this kind of weird, undefined behavior, ambiguity? You initialize your variables, right? So like, now we have initialized it. Now there's no ambiguity. We know exactly what's going to be there. So like, if someone here has said like a equals a plus 1, we know that's always going to be 1 because we know that a will always start at 0. Whereas before, you know, we're playing Russian roulette basically. Okay? Don't play Russian roulette. It's not good for you. All right. So in this case, with a class and with members of that class, member variables of the class, you can also initialize in many ways. I'm going to show you what a constructor is in a little bit. But for now, let me show you sort of like the easy mode of initializing things. The speed variable, you can initialize it by literally putting an equal 0 here. But again, this will only work in C++11 or later. If you do this, you're in business now. So every time that you make a car, you know for a fact that speed will be set at 0. I don't know about you, but if you're spawning cars in a simulator, you probably want to spawn them in a static, you know, motion, unless you're, I guess, like GTA and then moving or something. But even then, spawn them static and then give them a speed. So, yeah, forget about that. Point is, you want to initialize your variables always. Same thing applies to objects and classes. Okay, so that's a good thing to initialize. Status, you know, that's a good one actually. You got. I don't like the name status because it doesn't tell us much about this. I think what we're trying to say is whether the car is on or not. So let's go ahead and use the word is on as the variable name. And then we want to start out with the car always being off. So, moment of thinking here. What is, I think it's lowercase for the false. Or I could have put a 0 there, and that would also coerce to false. The reason I'm thinking is because I think in Python it's uppercase and C++ is lowercase, and that always kind of flips my mind backwards. So, but yeah, try it out at home, figure out which one it is, leave a comment below. Okay, max speed, that one is, I'm going to make it a variable, but you could make it a constant, but then you can't really change it, and you might actually want to initialize it once, but then don't change it in the future, but you do want to be able to set it, because like different cars may have different maximum speeds. So I'm going to make it an integer. I would have made this an upper S, but I don't feel like erasing that. I'm going to make it, I get a default, but it can be edited. 120 miles per hour, maybe. I think that's what they do sometimes if they have a governor. I'm going to not put the bin one just because we already have it long enough as it is. So yeah, that's how we get all the variables. Let's get some of the functions in there too. So for the functions, we're going to pick, hold on. It dropped like ink on me. Ooh, let me clean that from the floor. When you squish the tip, it explodes out. So very cool. Out of context, very cool. Okay, where's the cap? So now my hands are all colorful. Now it really looks like an art class. Okay. I should probably buy more markers. Based on the consumption rate of the markers, I estimate that in a month we'll be out of marker. Okay. Let's go ahead and put some functions. So let's do accelerate. So I feel like accelerate would be a void function because it doesn't really need to return us anything. Now, you could also use it as an error state, like it returns an integer that represents an error, such as like if there's an error accelerating, such as if you hit the max speed. So because of that, I am going to make it actually a Boolean. Yeah, so we'll return true if the acceleration was successful, false if the acceleration was unsuccessful because we were over our max speed. Yeah, I think that's fair. There are no parameters for this. And so, like I said, our accelerate function is going to basically change our speed member variable. So here's the cool thing about this. Objects. So this is an object now. When we actually make the car, one car is going to be one object. That one car has a speed, whether it's on, and a max speed variable associated. So if we make two cars, they each have individual speeds with the statuses and max speeds. They are unique. They may share in terms of efficiency. What the compiler will do is it will share function code. So like the accelerate function code, there'll only be one copy of that, so that the executable is not that big. But it will make sure that each car has its own speed variable. So that there's like, imagine like you accelerate your car in the simulation and like the car next to you accelerates too. That would be not good. That would definitely not. That would get you fired. So yeah. Because of that, because each one has its own sort of variable, we can take advantage of that. And we're able to reference to it by merely just writing the name. So like we could write speed here and then increase it that way. And then, you're set. So let's go ahead and do that. However, because I want to make sure that I don't go over max speed, the first thing I'm going to check in this function, and I'm going to write it here just to optimize my space. I'm going to write an if statement. I'm going to say if speed is currently equal to max speed, that means we're already our max speed. So that means that we really can't go faster. So in that case, we don't want to increase the speed. So we're just going to return false. Okay? And that'll be a flag that like acceleration failed. Otherwise, you don't really need to have the otherwise because the return will it's kind of spaghetti code, but whatever. Otherwise, then we can actually accelerate it. Now, how do we accelerate it? It's just going to be a +1 acceleration, and then just call the function repeatedly. Not the best way to do it, but it'll work for now. We can just use like max speed plus plus, something like that, and a semicolon. Okay, and there's our function. So just imagine that's in here. All right. Again, I'm trying to save space. And then as you saw, we did have a break function, so I'm gonna go ahead and do the break. That one is void. We could do some error checking in that one too, but I think we got the point. That one, you could just do max speed minus minus. The kind of error checking you would want to do is, in this case, the way I wrote this function with the minus minus is that if you're at 0 speed and you try to brake, now you hit negative speed, so you're going, I guess, backwards. Okay, not a bug feature, I guess, but not one that we want right now. Okay, and then for start and stop, I'll just do one of those. I'll do start. Or I'll just call it toggle, actually. Let's toggle. Toggle, all it's going to do is going to do the opposite of what it currently is at. So is on is going to get the opposite of is on. So that'll flip it. Yep. It ain't much, but it's honest work. So there you go. Obviously, multiply this times 100, now we're talking about possibly a decent amount of car with decent amount of telemetry and operations that you can do on it. Right? So this is cool because now you can actually have fun with this car and do things to it. And if you need to build 10 cars, then you just make an array of these. So let's go ahead and actually create an object and create a car. So let's go ahead and do it up here, just so I don't have to erase this immediately. If I do erase something and I need to refer to it, you're on YouTube, you can just use the back slider and go back and take a look, take a screenshot, and then put it next to you. So in main, let's say that we want to make a car, a single car. We write the name of the class, and then we go ahead and just write the identifier that we're choosing. So let's just call it Tesla 1 or something. Let's call it Tesla, just Tesla. Okay? That's it. You have created a car. Now, you didn't initialize anything here, but because of these equal zeros on the variables, you are in fact initializing all of these. So that's pretty nice, right? That's convenient. You can make another car. So I guess this one we're going to call it T, very original name. And so this car has its own speed variable in it. So if I go in and say, I want to accelerate my Tesla, and I want a plate, I want to see if I go to that, 0 to 60 in 2 seconds. So I'm going to go ahead and say accelerate. I don't know what it's about today about the word accelerate, but I keep misspelling it. Might be due to the fact that I am recording this at 1 in the morning, but I needed it to be dark so that the magic works with lighting. Yep, definitely 1 in the morning. Okay, so in this case, here you can start to see the power of object-oriented programming. It might just be me, but this looks beautiful. It's just we were talking about self-documented code. This is very self-documenting. I'm saying accelerate the Tesla. You should still write some documentation like what we're doing here, but this tells you what is happening. This versus some random variable where you would do +1 or something, it's just very clean. Okay? You can also toggle the other car, so T Oh, by the way, that would be another error check you could do with accelerate and brake. You might want to check if the car is on first. So you would do something like if on, otherwise return false true. Also, one thing I forgot to say here is after you increase that, return true so that it doesn't yell at you that you're not returning a value, and then you can look at that value later. So if you wanted to check whether this worked or not, you could do an if statement here. But yeah, so toggle. You go, turn on your car. You might even put in here like a little CS statement that says like broom broom, so like sign that your car is on. Although it's electric car, so it wouldn't really do broom broom, I guess. More like or something, I don't know. It's a programming class, not a sound class. But yeah, so a couple of things that I want to emphasize about creating a class is, even though you've done it when you're doing structs, is the syntax. So the syntax of a class is going to be the word class, some sort of identifier. The same rules apply that they did in 135. So identifiers can start with a alpha character, so A through Z, uppercase or lowercase. They are case sensitive. It can, after the first character, have a number in it. So, you know, this is a good variable name. This is not a good variable name because it starts with an integer or a non-alpha character. So you could also have underscores in the names, and you can start with an underscore a variable name, but it is discouraged as that is reserved for system variables and other nastiness you don't want to mess with and accidentally overwrite, or just it won't compile, I guess, because it's C++. So yeah, identifier there, and then your curly brace, and then you have all the body of your functions and variables, which are of the same type, identifier, assignment. For functions, you have your return type, your identifier, your parameters, and then your body of the function. But ultimately, when you finish doing everything, you do another curly brace and a semicolon. Important not to forget that. I tend to forget it myself. That's why I want to remind you. But yeah, that is how you declare a class. So this is cool. And right now, you might be like still not convinced on the object-oriented programming hype train, but we'll get there. Before we do that, though, let's talk about initialization again. So while you can initialize this way, I did say that this only works after C++ 11. So you might be asking yourself, how would you initialize a variable if you were running this on a language, a version of the compiler that was older than C++ 11? Or also, initializers are useful for more than just this, like simple, hard coding things to 0 or something like that. And so for that, we have a special function that the classes have. Well, structs do too, technically, because they're the same, but primarily for classes, because this is not something you would see, I think, in C. And that is a constructor, okay? So, and that's dangerous now. Now I claim that C doesn't use constructors, but it might, and I just don't remember, and someone's gonna yell at me, but that's fine. We're gonna have to make a compromise here and get rid of something, so let's get rid of toggle. And let's just go ahead and write a constructor, okay? Let's erase this. I don't know whether it did that anything, but it's fine. So I'm gonna sit down for this, okay? So what is a constructor? Do I have a little definition? Yeah, so so let me go ahead and just define what a constructor is first, and then go from there, okay? Constructor. So a constructor is a special function. It's actually really special. It's kind of trippy. You'll see why in a minute here. But it's a special function that runs when a class object is instantiated. Okay, so again, I'll repeat that. A constructor is a special function that runs when a class object is instantiated. So let's kind of refresh on this word. I've said it a couple of times today, but I haven't formally defined it either. So when you create a class, what you're doing is you're sort of building the blueprint of what the class will contain. When you are actually making something out of that class, we call this an object. So this is now an object of the car type class. Okay. Creating that magical process of creating an object out of a class is called instantiating the class, and that's what instantiating is. It's sort of creating the class. Okay, so when you instantiate something, you're actually creating it. When we learn about dynamic memory allocation and we learn about new and delete, you're creating an object dynamically. You're also instantiating in that process. Okay. So why is this special function? Why is it called the special function in this constructor? Well, let me tell you why. The reason why is because normally you have seen really two types of functions in C++. What are those two types? Think about it for a second. All right, that's enough thinking. You have seen value returning functions. In fact, you see it right here, such as this one, and yeah, this one's a value returning function. And you've also seen the other one that you see right here, which is our void functions, so functions that don't return a value, right? The big difference is that you want these to return something and these you don't. Otherwise, bad things happen. So what could there be as a third option? Like, what either returns or doesn't return, right? Well, constructors are sort of like that third weird Twilight Zone-ish kind of option, because constructions are not value returning functions, but they're also not technically void functions. They're just constructors. So let me go ahead and write a constructor first, and then kind of go from there. So the constructor is going to be this special function that has to have a specific name to it. And that name has to be the same name of the class. So in this case, our class is called car with an uppercase C. So our constructor is going to be called car with an uppercase C. Okay, now I'm going to start with the easiest version of the constructor, which we call the default constructor, which is always given to you automatically, but you just don't see it as happening behind the scenes. And that has no arguments inside of the parameter parentheses, or argument parentheses. And then you have a body to it. Now that body can be empty, or it could have a billion different lines of code. It's a function after all. So that's it. That's a constructor right there. Cool. What do I do with it? Well, this function, this magical function called constructor, is going to run whenever you first create a class. So when this line of code actually gets executed, the first thing that happens, if it looks at this class code, it finds the constructor. There might be more than one, as remember function overloading, that kind of thing happens with constructors too. You can overload constructors. But yeah, so you might have a car here, and you might have a constructor here, a single one, so it's going to go to that one, and it's going to run whatever code you have in here. It doesn't even have to initialize things. It could just be any code you want. In fact, I'm going to say car object created. Okay? It's just going to print out that function and then done. So whenever you see this line of code, when it runs it, you're going to see a cout statement that says car object created. And that's it. That's your constructor. Now, while that is cool that you're able to print things in there, what it really should be used for, and what it's usually used for, because it runs when the object is first created or instantiated, this is the perfect place to construct or to initialize your variables. So, for example, if I didn't want to initialize my speed right here, if I just made it like a random variable, uninitialized, I could do that here by just writing a line of code that says speed equals 0. Okay? I could do that. Now, I could do it both ways, but that's kind of weird. I don't know why you would. But, yeah, that's how I did it in the old days before C++11 came out and you could do this kind of thing. So, that's the most simple version of a constructor, and it's the one you get for free per se. Because technically, all classes have a constructor. But even if you didn't put this in there, like, the code would still run and compile. It just would not, you would not be able to edit these things when it's being constructed. Okay, cool. However, like, you know, if that's what the constructor can do after C++11, you're like, whoa, that's lame, I can do this, like never touch that again. Right, but let's add more flexibility to this. Remember that our max speed is something that we want to set when we first create the car, not something that we like have to set later, because again, object-oriented programming is making your life easier, not harder, and one of the ways it makes it easier is by initializing things automatically and potentially saving you code by setting things the way you want them when you first make the object and not later, so that, you know, if like you could have a line of code here that says like t dot max speed, you know, and then set that like there to like, I don't know, 60 in this one, slow car. But like, you created the object here and you set it here. In between here could be a million different statements that maybe you know not to do anything, but someone else is going to come in and they're going to put a accelerate in there, and you haven't set the max speed, and you know, bad things can happen if you didn't want that to be that high, for example. Like, you got a traffic ticket or something. Okay, so constructors, you want them to actually do their job when the object is being created, so that you don't have to think about that. It's like a do and set up and forget scenario. Okay. However, like, you know, you want to, a constructor, like, you want to set the max speed at the same time, then you need a way of sending that information to the constructor. You can do that because this constructor has the ability to have parameters in there. So I could go ahead and put a variable here. I'm going to call it int m. And yeah, let's use that for now, like that. And so now we have not a default constructor. We have a constructor. It's like we're overloading the constructor. Now we have one that has an m parameter in there. However, if you just run this code, it's going to give you an error. It's going to say that it needs a default constructor. So you would still need to have it somewhere else, something that had something like that. So you get away with not having a constructor at all, but if you do add one like this, then you still need to add the OG one, basically. Of course, if you all know default parameters, then you can get your cake and eat it too or something. So like, you know, I can do something like that. If you don't know what these default parameters are, then just go ahead and Google default arguments or default parameters in C++. Basically what it's doing, it's saying if you've called this function without an argument, then this will automatically set this to 120. If you call this with a parameter, so like if I say car 50 versus car, in this version m will have 120. In this version m will have 50. Okay, so that's how default parameters work. Trivial stuff. Even if you don't know it, I'm sure you can pick it up in 5 seconds. It's kind of a thing where you just gotta remember it. But anyways, the reason I do this is because then I don't have to have a default constructor and then also have this sort of overloaded constructor. I can have them both in once. So now that I do that, all I have to do is set my max speed to be equal to whatever m is equal. Voila! We have now basically created a constructor that is actually useful. Because now, when I make a Tesla, you know, I can either not set it to anything and the max speed automatically gets set to 120, but I could also set it to like 100. And so now, in this version, the max speed is set to 120 for Tesla, and for T, it's set at 100. This looks a little trippy because it looks like a function call, but it's not. It's still a object declaration. You're still instantiating T, a Tesla there, or sorry, a car. But yeah, so a little trippy. Gotta get used to that, seeing that, but it'll make sense later on. Okay. So these are your constructors, and they're very useful for initializing things. There are also destructors that I'm going to briefly talk about. But before I do, I want to show you one more way that you can initialize variables in a constructor. Okay? So let's just say that you wanted to initialize the speed to 0 here. Okay? Going back again to not initialize. In fact, furthermore, You also want to, I guess we're going to break a rule I said earlier about like the car not always starting in a non-moving state. So we're going to make a second argument here, and that is going to have another variable. Yeah, make it a double. We're going to call this, well, let's call it speed. Well, I'll call it SP, but then I'll call it speed. I will call it speed, but I want to show you something first, and if I call it speed, you're going to get confused, so just trust me on this. In fact, S for now. And I'm also going to use my default arguments, which is just going to be 0. So by default, the speed is 0, but I have the power to not be 0. So like now, if I do this like that, then that gets set to 100. But if I do something like, if I have to set the max speed to something so that I can set the second one. Otherwise, I can't just set the second one because that's how default arguments work. So I'll leave that like that. But this one, I'm going to set it to be moving at 10 miles per hour. Okay. So in this scenario here, I want this S to basically set up the speed variable. So while I could do it here by just writing a line of code that says speed gets S, that's no fun. I want to show you a different way of doing it. Okay? And the reason why is because I'm not saying like you should know all these ways and like keep switching back and forth every 5 seconds on ways to freak people out and make you seem smart. It's more because like I want you to know so that if you see someone else's code and like they're doing it in one way that you're not used to, you don't just freak out and you're like, what the heck is going on? You're like, okay, I'm used to doing it this way, or I'm used to doing it this way, but I know the other ways. So I can read other people's code and know what is happening. That's why I'm showing you all these ways of doing it, so that you can actually understand when people do it in a different way than what you're used to. Okay? But this version that I'm going to show you will come back to us when we talk about inheritance. So it's cool too. So what we're going to do is kind of trippy. We're going to put a colon there. And then from there, we're actually going to put the variable name that we're trying to set, which is speed. And then we're going to set some parentheses. And now we can put our curly brace to start the function. Inside of those parentheses, we're going to put in the variable that we're actually setting it with. So in this case, S. And you're like, whoa, this looks weirder now. But it doesn't, because remember, I just told you this is okay. Like when you're creating an object to have parameters to pass in arguments, you can kind of think of the same way here. Speed is a data type. Car is a data type now. It's a custom data type, but it's a data type, right? So we're actually initializing the data type with some parameters. Similarly here, we're initializing the speed data type, which is a double, with a parameter, which is S. So what this little fancy piece of code is doing is it's just setting the speed variable to whatever is inside of that. And I could hardcode that. I could have put a 5 there. In fact, imagine that's a 5 and not an S. It's an S, by the way. But imagine it's a 5. Then that would just set the speed to always be 5. In this case, it's set to that. Now, why was I being cheeky about the variable name? Well, if you want to freak people out, and actually not freak it out, actually I think this is the way to do it, but some people kind of get confused when I do it this way. That's why I said I wouldn't do it. Is I could have actually written this like alternate universe. I could have written this like this. And then put my colons. And then write this like this. And of course everything I see here is the same, and afterwards it's the same. This would have worked too. But the reason people get confused is because they see like speed, and they're like, okay, like, what is happening there? Well, scoping rules are happening. So you all remember scoping from 135. It's important if you don't, so refresh it. But ultimately, like curly braces change scopes and things like that. So within this function, the word speed is referring to which one? You're like, which one? Well, it's probably referring to this one here. So like this one is referring to this variable here. But because this area here is only meant for class variables that you can initialize, just like the speed variable, then there's no scoping problem in the compiler understanding that this is the class variable and this is the function argument or parameter. So this one, okay? However, some people really kind of, when they're fresh to C++, they're not familiar with that sort of scoping and they get confused. So if you do, then just don't use the same name. I think it's cool because like it's harder, like this works because you're like, well, speed I can put an S, and like that works until you have to things to start with an S and then you get confused. So that's why using the same name is cool, but you really got to understand what is happening here, otherwise it makes things worse. So that's why I didn't want to show it to you first, but just wanted to make you aware of it in case you see it. Okay, we are at the 1 hour mark, but last video was short, so this one might go a little bit over the hour and 15. So, okay, although we're getting close. We're getting close to finishing at least the basic one. So, that's your constructors. I think that's all I want to say about constructors. Maybe one thing I'll add is, again, this looks trippy because like there's no value, no int, no void, nothing. This is literally the function right here. So this might kind of throw you off as like, oh, that's weird. And there's no return statement either. Just embrace it. Embrace the fact that this is just a function that exists and this is how the syntax works for it. Moving on kind of thing. All right. Like I said, there is a destructor that exists. Just like a constructor runs when the object is first created, the destructor runs when the object goes out of scope. That might also, again, scoping rules. You might get confused. What does it mean when something goes out of scope? Let's say you make a variable, make a function foo. And inside of that function foo, you have a variable called int. That int variable is local to the function foo. While the function exists, that variable exists. But when the function terminates, there is no reason of keeping that in the function. Like to keep that in main memory. Because you're never going to use it again. Because even if you call the function again, it would be a brand new instance of that int variable. So when the function ends, we say that the int variable goes out of scope. Okay? So, void f, and here I have an int a, and there's some code, and the code ends. This int a only exists from when this function is first called to when the function terminates. Outside of that, that int does not exist. What's the exception to that? Statics, right? So you have a static variable, so if you add the word static to this, then the game changes. The rules of the games have changed, basically. In that case, that variable does persist between function calls. And it can be very convenient for things like keeping track of how many times a function has been called, like a counter. There are also static variables for classes. We'll talk about this in a different day, and maybe that'll be a good refresher in case you're not familiar with static variables and functions. Lots of stuff, right? That's why you gotta make sure you put attention in 135, because like we're talking about the cars today. We are on a racetrack, and 202 is like, the other car just arrived, and we're speeding off to continue the race, and we're going 10 times as faster as the 135 car. So you got to make sure you're awake and motivated and ready to keep going. Okay, so the destructor, like I said, is running when the object goes out of scope, and so let's go ahead and do a sample of the destructor. So let's just make some space here, change colors since we've been doing that for a while. And go for it. Okay, so the destructor is also going to be kind of weird, but we're kind of used to weird now. So the destructor is going to always be named again by the class name, same like casing and everything. The destructor should never have parameters, so it's always just going to be the two parentheses like that. And then you have the thing that separates it from the constructor, which is the little tilde or curly line. I think tilde is the appropriate name. That is what tells the compiler that this is in fact a bona fide destructor. What is that for? Right now, we're really not going to use it a lot because it's not really meant to be used unless you're using dynamic memory allocation. So, you could use it to like see out something. You could use it to like set some variables, like a static maybe. Yeah, static would work. But everything else is like going out of scope anyway, so it's kind of been gone. So like you don't need to like erase values and whatnot. So it's not very useful right now, but trust me, when we learn dynamic memory allocation on like week, week 4, then it's very useful because that's how we deallocate memory. And that's going to be its main usage throughout this course, is to be able to deallocate memory to avoid memory leaks, which are something that we don't want, right? If any of you play video games, you will know what memory leaks are, which is when you're playing a game and after a while it starts eating RAM and consuming more RAM. By that I'm saying it takes more RAM if you're looking at the telemetry of the computer. And of course, when that RAM hits the amount that you have, it's either going to go into the swap file and like super slow down, or it's just going to crash your game. You're going to be pissed. So, final circle, about to win, you know, Warzone or Fortnite, and then the game crashes, and you're like, no! So, yeah, no floss for you. Okay, so, yeah, Destructors. They exist, they're useful, but we're not really going to look at them for now until a couple of weeks from now, but they are there. Okay, so you've seen a good example of a class. There is one more thing I want to show you about a class. And so for that, I'm going to need some space. So let's go ahead and erase this. And then let's go ahead and let's erase this and then just add space here. And yeah, I think this will be good. Okay, so keep looking up, it's like something's tickling. It's like my shorts have something. Okay, so far, what I've been doing, particularly for the functions, is what is known as an inline function, which means that inside of the class declaration here, and definition of the class, I am basically putting in not just the function, but the function body. Okay, that works and it's fine, but when we start doing multi-file compilation and when your classes in general just become really big, it's not a good approach because it's kind of harder to just like, if you really want to, you know, remember what we're doing this, making your life easy, right? So if, you know, a class is nice when you just have a bunch of variables and a bunch of functions, just like the function name, not like the body of the function, because then you can see very quickly what you can do with that class. But when you start actually putting in all the code of the function, like it just becomes really long and trying to scroll through that is not very nice. So what you can do to alleviate that issue is you can actually define your functions outside of the class. So let's go ahead and do that really fast. So we had the break function, right? So let's just throw it in here. Void break. Okay, now I could write the body of the function here, like I said, you know, you could do that and then have like a million different lines in there and then things get spaced out nastily, or I can just hold off on that. And of course, all the way to the bottom of this function, or sorry, this class, we have our curly brace and then the semicolon. And then beneath that, somewhere, is going to be this code here. We need to define this break function. If you don't, well, if you don't define it and you don't call it, the compiler might let you compile, but you're definitely going to get an error if you try to call it because it's like, yo, I don't have a body for this function. I don't know what to do. Bad things, crash, right? Well, not crash, it's not compile. So ultimately, if you want to define it, but you've already finished writing your class and you're not doing it inside of the class as an inline function, you can do that outside the class. And the way you do that, obviously, if you just try to say something like break, then this function is just a global function. It's not a function that is member of the car class. Why is that the case? Because, well, I'm going to have a void there, but because like there's nothing linking this function to the class. Even though you're like, well, I have the word break here. Yeah, but like there's nothing related to scope that's telling it belongs here. So how do we solve it? Well, if you have a scoping problem, you solve it using the scope resolution operator because it resolves problems, as the name implies. It's scope resolution operator, right? In fact, let's write that up here. scope resolution operator. Now, what does that look like? 4 dots. It's like colons. We already saw colons with the constructor. Now you see more colons. You're like, this is getting out of hand. Now there's 2 of them, right? Leave in the comments below where that's from, and you get a thumbs up maybe on the thing. Okay, so the way you use the scope resolution operator for telling the compiler that your break function is actually trying to define the one inside of the class is you're going to write this really cool syntax. You're going to have to work. Well, first of all, you're going to write the return type. So it's going to be void because it's a void function. But if it was an int or something, you would just write the word int there. And then you're going to write the class that this is belonging to. So in this case, car. And then you're going to write the scope resolution operator, like that. And then you're going to write the function name, which is break. And then from there, everything goes on. So you have your parameters, your curly brace, and now you're going to have all your code there, and then your closing curly brace. So really, the only difference here is going to be this. But it's important that it's there, because that tells it that this is not any ordinary break function. It is the break function for your car, which is important because otherwise your car will crash. So, yeah, important, right? So, scope resolution operator tells it belongs there. That's what I'm dealing with. Okay? Again, if it was a value returning function, this could be like an int car colon accelerate. You could also do this with constructors. So if I wanted to add another constructor into the mix here, I could do that. However, constructors don't have a return type, so you don't need to put anything there. You would just do something like car colon, and this is trippy, but you put car again because it's the name of the constructor, and then maybe you have another one here. Maybe you put the default one out here, I guess. So let's get rid of it. Oh wait, that's the destructor. Oh well. It's gonna yell at you because it's the default parameters. Let's just make another constructor that has 3 parameters. Int A, int B, int C, okay? And then your curly brace and your bunch of code. All right, you get the point. The point being this, all right? So when you're writing outside of the class, every time that you want to refer to a function, you use this. And actually, this will work too for variables. However, it's important to understand why it only works for certain kind of variables. And that is because if, like, you know, going back to our instance of the car, so car T or Tesla, you know, if you do something like T dot speed, you know that it's referring to the speed of this specific object of the car, right? If you do something like this and say car speed, technically speaking, this is not wrong in the sense that, like, you're referring to the speed variable inside of the class car, and there does exist a speed variable inside of the class car. However, this variable here is created when the car object is created. Here, you're not referencing any specific car object, and so because of that, it doesn't know. It's like, okay, whose speed? Like, which car? You gotta tell me which car, otherwise I don't know. So because of that, that would not compile. There is one exception, and again, it comes down to statics. When you have a static variable, so very quickly, if I make a static int called, what would be a good thing for static for this? ID. So each car you make has an ID. You want, you want a counter that increases that every time so that you can extract it from that. So maybe instead of ID would be like count for how many cars have been created, and you keep upping that in the constructor. So in the constructor, you say count plus plus. This is not like a random ordinary example. This is something that in the past when I created my assignments, I used to love to do. It's like whenever I make objects, I make a count variable, and then I make a normal variable that's like an actual ID, so that it's unique to each object. So each object has a unique ID, which is pretty neat. Keeps nicely track of all things. But yeah, so if you have something like this, then it makes sense to actually do something like car.count, because it's static. and a static variable is shared amongst all objects of the class. So that's the one exception where that will work. Outside of that, that will not work, and bad things will happen. Okay? So yeah. But again, what you will mostly be using the object approach, or class name : is for defining functions outside of the class, which is a nice thing to do because it makes your actual class declaration small and makes all the definition stuff like, you know, elsewhere. So like this would be on a C++ file, or sorry, this would be on a header file, and this would be on a CPP file. And then you let the linker do its magic. Okay, let me see. Okay, I could go further, but we are out of time. So I will go ahead and call it a day on this. Ultimately, the name of the game of what I set up here in the beginning is object-oriented programming. But before we can go back to really talking about the core principles, that encapsulation, polymorphism, abstraction, and later on inheritance, I have to explain abstraction itself and what that means. So we'll pick it up from there in the next video. We'll start talking about data abstraction, data encapsulation, which for now I'll say, think about it. What we've done here is we've encapsulated the data related to the car. So everything is nicely contained inside of the car object, right? We have all the operations and all the data that are related to this one car in here. So it's all in a nice little bucket, I would say, or a pill, like a capsule. Encapsulation. See that? People thought about these things when they came up with these names, I guess. So in a way, you already seen encapsulation, but you know, I'll properly define the term next time. And then the concept of data abstraction and information hiding will come in when I talk about public. So we will revisit maybe this example and see how maybe we want to make something like this hidden from the user, because you may not necessarily want all the data that you have available for a class to be accessible to a user, because the more you make accessible, the more something is going to break, because people like to mess with things. And you know, it's like, think about a car. You don't let people mess with the ABS brakes, right? Like, you either let them turn them on or off, but you don't let them like modify like the thresholds or how an ABS works, like those actual internal variables and data. Because if you did, people would mess with them and like the car would just screw up and crash, and then they would sue the company and like be like, yeah. So what do the developers do and the car manufacturers do? They block that off. I said 100% secure? I'm not sure. Probably not. Probably you can hack in and tweak some things, but you're breaking warranty and you're probably risking your life if you don't know what you're doing. So they make it hard. Not impossible, not hack proof, similar to how what I'm going to show you with public and private and protected is making it harder for you to accidentally change things that you shouldn't, but it's not by any means hack proof, because you can access private variables, and I will probably show you that at some point. So yeah, there's a lot more to talk about this, but we are already over time, and I think that this is a lot of information to process. So with that, I will call it a day. I thank you all for watching. I hope that you are learning and following along and trying out these exercises. You're all, obviously, since this is a video, you can rewind and watch pieces again that you may have missed. But ultimately, make sure that you are following along so that you can keep up and the next video will make sense and things like that. Okay? So, thank you all for watching. Hope you enjoyed it. Don't forget to like, comment, and subscribe. And have a good day.